I had a really different idea than what I'm doing now. I was going to do my favorite stumble-upons. I don't know if you guys know what stumble is. And so I had all these, I'm a big nerd, so I had all these like really nerdy articles pulled up about cosmology and supercomputers and things. I was like, oh, I'm just going to hit them with all these random articles and you're going to think everything is so interesting. But then I realized a lot of my articles actually warranted explanation, so I chose my favorite. And you guys have to understand that my only credibility presenting this to you is that I've read the article, and you guys haven't. So I have some notes for myself, and it's really it really depends on my wording, so I am going to have to refer back to this, so please don't think poorly of me if I end up reading from this a few times. And one last note, like for this to work, this can't be a presentation. This needs to be a dialogue between you and me. Okay, I'm doing it on whether time actually flows or not, so you guys really need to tell me if I'm explaining something poorly, if it deserves more elaboration, because otherwise I'll just be rambling for the next however many minutes you let me ramble. So I'm going to pause and like look at you guys, and if I see people are cross-eyed and confused, then I'm going to slow down, but it would help if you guys just told me. Okay? Alright, good. Alright, so the passage of time is one of the most basic facets of human perception. Like we know time goes and it flows from future, like it's in the future and then it happens in the present and then it's in the past. And it seems like common sense, but this whole concept of time flowing from future to past is really at odds with modern physics. And Albert Einstein famously said that the past, present, and future are only illusions, even if stubborn ones. And so Einstein has come up with this impression due to his theory of special relativity, which denies any absolute universal significance to the present moment. And so I'm going to play this video on special relativity because I just learned what it is, and this video can explain it. It's a really weird science video. There's no like interesting science videos, I'm just going to warn you. So, yeah.
Imagine two observers, one seated in the center of a speeding train car, and another standing on the platform as the train races by. As the center of the car passes the observer on the platform, he sees two bolts of lightning strike the car, one on the front and one on the rear. The flashes of light from each strike reach him at the same time, so he concludes that the bolts were simultaneous, since he knows that the light from both strikes traveled the same distance to his eyes at the same speed, the speed of light. He also predicts that his friend on the train will notice the front strike before the rear strike, because from his perspective on the platform, the train is moving to meet the flash at the front and moving away from the flash at the rear. But what does the passenger see? As her friend on the platform predicted, the passenger does notice the flash from the front before the flash from the rear, but her conclusion is very different. As Einstein showed, the speed of the flashes as measured in the reference frame of the train must also be the speed of light. So, because each light pulse travels the same distance from each end of the train to the passenger, she can only conclude one thing. If she sees the front strike first, it actually happened first. Whose interpretation is correct? The observer on the platform, who claims that the strikes happened simultaneously, or the observer on the train, who claims that the front strike happened before the rear strike? Einstein tells us that both are correct, within their own frame of reference. This is a fundamental result of special relativity. From different reference frames, there can never be agreement on the simultaneity of events.
Alright, so as like I ended, what we want to draw from this is that simultaneity is relative. Two events that occur at the same moment, if observed from one reference frame, may occur at different moments if viewed from another. So if you and I are in relative motion, and an event that I might judge to be in as the yet undecided future might already exist for you in the fixed past. Okay, are we okay?
Say it one more time.
Alright, so if you and I are in relative motion, an event that I might judge to be in the yet undecided future might have already existed for you in the past. And now I think this is kind of a jump in logic, but apparently the most straightforward conclusion from this is that both the past and the future are fixed. So if you're a determinist, you should really like special relativity. And so for this reason, physicists like to think of time as laid out in its entirety, like a timescape, analogous to a landscape, with all the past and future events located there together. So I don't know what you guys kind of envision, but I kind of take it literally, and I imagine like a landscape, and wherever you walk is just a different time, per se. All right, so we don't think of time as flowing. We think it's all there. All this time is just there. All right. And so, completely absent from this description of nature is anything that singles out a privileged, special moment as the present, or any process that would systematically turn future events into present and then past events. So what we're trying to say here is that time doesn't flow. It's like all this time is present, but it's not flowing from future to present to past. All right. And this isn't just crazy physicists, this is crazy philosophers as well. Because it makes sense to talk about the movement of a physical object by seeing how its location varies with time. So, but what meaning can be attributed to the movement of time itself? Relative to what does it move? Whereas other types of motion relate one physical process to another, the flow of time is circular and it refers back to itself. Anything? Yeah. Okay, I'm going to turn the page. So by convention, that this arrow of time points towards the future. We go from present to future. This doesn't imply, however, that this arrow of time is moving towards the future, that we're flowing towards the future. It doesn't mean that we're flowing any more than a compass pointing north means that we're actually moving north. The arrow of time denotes an asymmetry in the world of time, not an asymmetry in the flux of time. And so by asymmetry, I'm going to use the example of an egg falling. Now, if time were symmetric, when we moved from future to present, we'd see an egg falling and splattering. And if time was symmetric, then when we move from past to present, or whatever the opposite of that is, then we'd see the egg come back up and come back together. And that would be a symmetric time. But that doesn't happen. The egg is intact, it falls, it hits the ground, and it doesn't happen again. Yeah.
So, do they relate this at all to like entropy? Is that the kind of...
yeah, a little bit. They look for an explanation for this lack thereof of flow in entropy. I'll get to that at the end.
Okay.
I don't really explain it because I don't understand it, but that's okay. At the end. So suppose that we do take this film of me dropping an egg, and it shatters on the floor. And I'm like, hey Roshan, I took pictures of this event happening. Will you please stack them from the broken egg at the top and the intact egg at the bottom? And you're like, yeah, sure, of course I can do this. And I give you a stack of pictures. You're the engineer of the week, of course you can do this. This is a simple thing. So you're going to stack the pictures up. And this vertical stack retains the asymmetry implied by the arrow of time. And that the same thing, that it's not symmetric. It's together, it breaks, and then it doesn't break and then go back together. It's just asymmetric. Okay? Alright.